Pleasant morning to one and all. I am Dr. Sumitra, an associate professor from the Department of Computer Science and Engineering. Today we are going to discuss all about ethics, biases, and interoperability in neural network. The ethics, the basic concern in neural network, the bias and the fairness, the neural networks and the deep learning can invariantly predict biases present in the data used for the training. For example, the biases related to the race, gender, or a social economic status can manifest in the model prediction. Ensuring the fairness involves detecting and mitigating biases during the data collection, pre-processing, and the model training process. The privacy, which is all falls under this neural network, may invariantly leakage effective information from the data, leading to the privacy and neural networks. The techniques such as differential privacy and the filtered learning aim to mitigate these risks by protecting individual data points or learning from a decentralized data source. Transparency and accountability. The lack of transparency in how the neural network making a decision can lead to disgust and the challenges in holding a model accountability for their predictions. The ethical guidelines and the regulations such as general data protection regulations in Europe empathize the transparency and the right to handling for automated decision. The social implications where the deployments of these neural network in sensitive domain can have a profound social implications impact individual lives in the sociality structure. Ethical frameworks such as AI and ethical guidance aims to that AI technology benefits a society while minimizing the harms. The data biases where the neural network learns a pattern from trying the data. Bias presence in the data can lead to bias prediction. The technique like data augmentations, reverse data collection, and bias reduction algorithms helps mitigate data biases. Algorithm biases is also there, where this algorithm biases fetch the neural network architectures or the training procedures can introduce biases. Regulation technique, careful feature selections, and biases where a varying algorithm can reduce algorithmic biases. Evaluation biases where evaluation metric may not definitely focused on this with a perceived as a black box due to their context or non-linear nature. The technique like feature visualization, silence map, and model distillation aims to improve the model transparency. XAM models prevents insight into how the neural network make prediction, enhancing the trust and facilitating the model debugging. Examples include attention mechanism, rule-based explanation, and post-how interability techniques. A legal and the ethical requirement was focused on GDPR mandated and the rights to explanation for the automated decision driving researches into interoperability AI. The types of biases, as I state in the neural network about the data biases, algorithmic biases, and representation biases. The challenges and the ethical implications were the ethical AI designs integrating ethical considerations into the entire AI life cycle from data collections to the deployment to mitigate the biases and ensure the fairnesses. The biases detections in mitigation, developing an automated tools for detecting and mitigating the biases in neural network, ensuring the inequitability outcome across the diverse populations, and enhancing the interoperability and the interpredictions too. The featuring the developing more robust and initiating XAI methods to enhance trust and facilitating the border adopting for AI techniques. The importance, as I stated about the interpredictability, where developing more robust and initiative methods to enhance the trust and facilitating the border of AI technologies. And these challenges will help you for the better understanding of ethical considerations for the entire life cycles from the data collections to the deployment to mitigate the bias and future fairness and developing an automated tools for detecting and mitigating bias in future neural networks and equalability across diverse populations. Hence, I conclude by stating a few points, the basic evaluations that carried out in the meta learning for the further processes. As I state you, by the neural networks can diversely ensure the fairness involving the detecting and mitigating biases during the all data collection process and pre-processing with the model training phases. I hope you're clear with this concept. Thank you one and all.